Welcome to my channel once again. In our previous lesson, let's have a recap. We treated electrolysis. We said electrolysis is a process through which current is passed through a solution of a small thing or a compound of electrolytes. So in this aspect, when current is passed through them, they decompose. When they decompose, they give two ions, the positive and the negative. We talk about the terms. In electrolysis, we talk about electrolytes. Electrolytes are substances that conduct electricity. We talk about electrode. Electrode are substances, they are in form of wires or pole through which current enters or leaves the system. We talk about the cathode. We talk about the anode. We said the anode is a positive electrode, while the cathode is a negative electrode. So in today's topic, we'll be moving directly to electrolytic reaction. Electrolytic reaction. So electrolytic reaction is a redox reaction since there's a transfer of electron. So we said we have the cathode, and the anode. Said oxidation occurs at the anode. So a reaction that occurred at the anode is known as anodic reaction, or preferentially written as anodic half reaction. So there is a reduction reaction at the cathode. So there's a simultaneous reaction at the cathode known as cathodic reaction as well. There's a reduction reaction, cathodic reaction, or cathodic half reaction. So what actually happened during electrolysis? Products are formed at each of these poles. When products are formed at each of these poles, we said metallic hydrogen gas. Or metals are preferentially discharged at the cathode. So at the anode, what actually happened? No metals except hydrogen is preferentially discharged at this part of the reaction. So the overall reaction is obtained when we add, there's an algebraic addition of this reaction that happened here and the reaction that happened here, known as anodic reaction and the cathodic reaction. When we add them together, we have the overall reaction that occurred at this electrolysis. So what actually happened here is that when substances, when they are broken down into two, as I've said before, we said they produce two ions. Each of the ions will find their way to each of these poles. So this takes us to factors that influence preferential discharge of ions. One of the factors that influence preferential discharge of ions, we said one, position of the ions. The position of the ions in the electrochemical series. We talk about concentration. We said two, we talk about nature of the electrode. So position of the ions, I've said in the electrochemical series, we say the higher the position, the more reactive such ions will be there. So the lower ions will be preferentially discharged, as I've explained before. So the concentration of the ions will play a vital role when the position of the ions are very close. For instance, in the electrolysis of sodium chloride, we said chlorine and hydroxide is here because the concentration of this chlorine promotes the discharge of chlorine in the electrolysis of sodium chloride. So chlorine is preferentially discharged. So that is when concentration comes in. Whenever the position of the ions in the electrochemical series are very close, concentration will play a vital role. So we talk about the nature of the electrode. We said electrodes that do not participate in electrolytic reaction, they are known as inert electrode. So what actually happened is that we have a carbon platinums, they are inert electrode. But in some cases, chlorine that is released attack platinum, one oxygen gas attack electrode. So in the electrolysis of sodium using mercury, we said sodium will be preferentially discharged because of the law between mercury and sodium to form sodium amalgate. So in this aspect, we're going to move to the next topic known as electrolysis of acidified water. Let's move quickly to electrolysis of acidified water. Electrolysis of acidified water. What do you mean by acidified water? When a small quantity of an acid is added to water. As I've said, if we should have H2SO4, let's use this as an acid, as a very good acid. When it is dissolved in water, they are going to produce two ions. We said when these two substances, they are passed through electrolysis, they decompose to form the cations and the anions. So what happened here, you're going to break into two. Going to have SO4, 2 minus, we have 2 hydrogen. Here we're going to have hydrogen ions plus OH ions. This and this will move to either the cathode, or what? Or the anode. As I've explained before, this will move to the cathode because it's a negative pole. This will move to the what? To the anode. This is what? The positive pole. So what actually happened? Let's talk about cathode. We said at the cathode, reduction reaction occurred. So when this hydrogen ion will migrate to this cathode. So since they are the same, hydrogen ion will be preferentially discharged. So it's going to discharge. We're going to have, we said, there's a gain of electron. We said hydrogen ions, when they gain an electron, they give birth to what is known as what? Hydrogen atom. So hydrogen atom cannot stay alone. It's not stable. So you're going to look for another hydrogen atom to react with to form the molecule, which is a gaseous hydrogen. When they come, they're going to have hydrogen gas. So what actually happened here, we said a reaction that occurred at this cathode is known as cathodic half-cell reaction. For us to include any of these participating species here, it must be stable. It must be stable. Since we have the reaction started from here to this part, you now ask yourself, will this hydrogen atom be added? Since it's not stable, it will not be added. We're going to move this way. We're going to add anything that is stable in this reaction for us to have this half-cell reaction of what actually happened at the cathode. So we are talking about cathodic half reaction. We are having stable at the reactant part. We have hydrogen ion, electron to give hydrogen gas. This is aqueous. So what actually happened here? We will actually mean that at the cathode, what is discharged is the hydrogen gas. So this one, let's write it somewhere. Cathodic half reaction. We said we have hydrogen aqueous plus electron to give hydrogen gas. So let's see what happened at the anode. We said oxidation occurred at the anode. That means there's a loss of electron. So this and this will be preferred at the anode. At the anode, what is SO4, 2 minus, and OH minus, that is the ions, migrate to the anode when the losses an electron. When one of them will lose an electron, because each of them, we are going to look at the electrochemical series, the position of each of them, which of them will be preferentially discharged. Let's come this way. We have SO4 minus sulfate ions here. We have OH ion. Like what I've explained, see the distance is far, the concentration is not going to play effect here. The position of the ions will play a vital role. So when the SO4 2 minus and OH is migrated to the anode, OH is preferentially what? Discharged. OH is preferentially discharged because of the position of OH in the electrochemical series. If OH is preferentially discharged, there's a loss of electron. Here you're going to have aqueous We're going to have OH plus electron is given out. So OH is not stable. We are going to have OH will react with OH to give water plus oxygen. You can see that oxygen here is not stable. Oxygen will look for another oxygen. Oxygen plus oxygen to give what? Oxygen gas. So what happened at the anode? The reaction that occurred at the anode is, we call it what? Anodic half reaction. Anodic half reaction. As I've said, whatever that is stable will be included in the reaction. Any species that is stable will be added in the reaction. So look at this one now. Reaction started from here as a reactant, OH negative, give birth to what? Electron is stable. Okay, let's leave that one first. We are going to have water is stable here. We're going to take water. We're going to take, since oxygen atom is not stable, we are going to leave oxygen atom. We are going to go for the what? The molecules that is stable. We are going to have OA, oxygen gas, plus this electron. So if you check here, we are going to have, we said at the anode, what is preferring discharge? OH is preferring discharge at the what? At the anode. So in this aspect, when we add the algebraic addition of this anodic reaction and this cathodic reaction will give us what? Overall reaction of this, what actually happened at this electrolysis. So in this aspect, we're going to balance this electron. We're going to balance this electron. So in this now, students should be very careful. Whatever electron you are adding here must be added at the cathodic reaction. If, for instance, now let's balance so that when we add the algebraic addition of this anodic and the cathodic, this electron can cancel each other. That is why we'll make use of same electron at the anode and what? At the cathode. Yeah, let's balance this equation. We have 2 hydrogen here. We have 1 hydrogen here. We have 3 oxygen here. We have only 1 oxygen here. So let's balance. Since this one is more complex, let's try and balance this chemical equation. So if we should have 4 here, we have 4 oxygen, 4 hydrogen. Here, it's going to lose 4 electron as well. 4 times 1, I'm going to lose 4 electron. Let's balance this atom first. We have 4 hydrogen. We have 2 here. 4 hydrogen, 4 hydrogen, 4 oxygen. We're going to have 2 oxygen here, 2 oxygen here. Since we have 4 electron here, it must lose what? 4 electron. So let's say this equation is balanced. Let's make use of this 4 in this cathodic reaction. If you are able to balance it with this cathodic reaction, let's say we have 4 electron here. 4 electron here, we'll gain 4 electron. Here we can balance it easily with 2. That means we are able to balance the equation with 4 electron on both sides. So 4 can go in both ways. All right, let's wipe this place so that I will explain what I've done here. We said at the cathodic we have 4 ion aqueous plus 4 electron to give 2 mole of hydrogen gas, aqueous gas. So what actually happened here? We are going to add the algebraic addition of this reactant and this reactant. So this overall reaction will now be overall reaction. We are going to have all the reactants should be at one side. It started with 4 hydrogen ion aqueous plus 4 OH ions plus 4 electron. Is that clear? So the reactant must be on the same side. We have the product here. We have hydrogen gas plus here we have 2 mole of water. 2 mole of water plus we have oxygen gas plus 4 electron as well. This 4 electron. That is why the essence of we having same electron at the cathodic and the anode, so that they can cancel each. You're going to have, since 4 electron is here, 4 electron is going to cancel 4 electron on both sides. You're going to have 4 hydrogen plus 4 OH negative to give 2 hydrogen gas plus 2 water plus oxygen gas. So in the electrolysis of acidified water, we said 2 mole at the cathodic, hydrogen gas is produced. 2 mole of hydrogen gas is produced at the cathode, while at the anode, 1 mole of gas, of oxygen gas, is produced at the anode. So the question will go this way. In the electrolysis of acidified water, what is the mole ratio of hydrogen to oxygen gas? In this aspect, we have 2 ratio 2 ratio what? 1. In the sense that we have 2 mole here to produce 2 mole of water to produce 1 mole of water. What will be given to you is that whatever that is produced at the cathode is the hydrogen gas. Whatever that is produced at the anode is what? Is the oxygen gas. You can see your different question in WAEC, in your JAMB, and your NECO examination. You'll be asked in the electrolysis of acidified water, what is produced at the anode and what is produced at the cathode? What is the mole ratio between the product that is formed at the cathode and that of the one that is formed at the what? At the anode. So this brings us to the end of this lesson. Thank you very much for watching. In our next video, we'll be talking about electrolysis of brine, which is sodium chloride, and copper sulfate. Thank you. Please turn on your notification bar so that you can have a constant notification of our videos. Thank you very much.